Hello, my dear students. This is the last part of the chapter Is Matter Around Us Pure? In the previous video, we had discussed about how to separate the components of air and even about water purification. Let us move ahead to discuss the last part of the chapter. So, we are going to discuss about physical and chemical change, about which already you have discussed in your 7th standard. So, to know about this physical and chemical change, first we need to know what are physical properties. Physical properties are those where there is change in color, hardness, rigidity, fluidity, density, melting point, boiling point. All these are the physical properties about which we have discussed in the chapter 1 as physical properties of matter, right? That is states of matter. So these physical properties, if it get changed, then such change is called as physical change. So physical change is one such change where there is change in physical properties. Change in physical properties lead to physical change. Whereas in case of chemical properties, there should be change in chemical properties. Then it is called as chemical change. So we need to know which are physical and chemical changes. Okay, before that, chemical properties andre ಏನು? Chemical properties means mainly it is inflammability, whether the substance will burn or not, and when it burn, what substance it will produce, and about reaction with other substances. What happens when substance react with the water or mixes with acid? Those things means chemical properties. If there is change in chemical properties, then it's called as chemical change. Okay, so coming to this interconversion of states of matter. For example, ice into water, ice getting converted to water, water to vapor. Though all these three appear differently, appears as different material, okay, appears as different material, but in reality, all of them are made up of H2O only, right? All of them have water in it and their properties, chemical properties remain same. Only physically they are either solid, liquid or gas. So interconversion of states of matter is always a physical change. Whereas in case of burning, burning is considered as chemical change. Why is burning considered as chemical change? Because during burning, it produces new substances. When new substances get formed and there is definitely a chemical reaction, then it's called as chemical change. So in case of chemical change, there is formation of new substance, whereas in physical change, no new substance get formed. Okay, so these are the main difference between physical and chemical change, about which you have already studied in 7th standard. So now sooner I'll show you some images. You should identify which is physical and which is chemical change. Okay. So going to the next slide. So what is this? Here a candle is burning, right? So you can tell that it's burning of candle is a chemical change, right? But in this burning of candle, there involves two changes also. Here, there is melting of wax, and there is burning, right? Burning of wick of candle, right? So two things are happening. One, wax is melting. The melted wax, if you will keep as such for some time, it will again solidify, right? So which change is that? Melting of wax is actually physical change, whereas burning of wick is a chemical change because it produces carbon dioxide and it produces other gases. Okay, moving ahead. So burning of candle involved two changes also. It involved both the changes, that is physical and chemical change. Now here a person is cutting a tree cutting. Cutting of trees with change. It is once the tree is cut, Again, same tree cannot grow. It is chemical change. Okay. Then here, rusting of iron, iron getting rusted. Rusting of iron involve chemical reaction about which we have discussed in metals and non-metals chapter of class 8. So it is a chemical change. Then fruit salad. How is fruit salad made, or any salad for that matter? It's just made by cutting the vegetables or cutting the fruits and keeping them mixed, right? It's a physical or chemical change. Is it cooked in during fruit salad? Any cooking is done? No cooking. So in case of fruit salad, it's just a physical change. ಯಾಕಂದ್ರೆ ಕುಕ್ಕಿಂಗ್ ಏನು ಆಗಲ್ಲ, ಬರ್ನಿಂಗು ಹೀಟಿಂಗ್ ಏನು ಆಗಲ್ಲ, ಫ್ರೈಯಿಂಗ್ ಏನು ಮಾಡಲ್ಲ, ಜಸ್ಟ್ ಫ್ರೂಟ್ಸ್ ನ ಕಟ್ ಮಾಡಿ ಮಿಕ್ಸ್ ಮಾಡ್ತಾರೆ. ಮಿಕ್ಸ್ ಮಾಡುವಾಗ ತಿನ್ನುವಾಗ ಆ ಫ್ರೂಟಿಗೆ ಅದರದ್ದ ಪ್ರಾಪರ್ಟೀಸ್ ಹಾಗೆ ಇದ್ದಿರತ್ತೆ, ಹೌದಲ್ವಾ? ದ್ರಾಕ್ಷಿ ಸ್ವಲ್ಪ ಹುಳಿ ಇರಬಹುದು, whereas strawberry can be little sweet, or if banana is added, that may be little sweet. So its properties remain the same, its nature remain the same. So making fruit salad is a physical change, whereas rusting of iron is a chemical change, and burning of tree, or sorry, cutting down of tree is a chemical change. Okay na? So moving ahead, here is a cooking of food. This is different from fruit salad. Fruit salad do not involve any heating, boiling, or even frying, nothing it involve. Whereas this involve boiling, and this involve steam cooking. Okay, in the steam it is cooked just like idli. Okay, so momos. So this cooking process is actually chemical change, because once it loses its property, again it won't be retained. ನೀವು ಚಪಾತಿ ಮಾಡುವಾಗ ಚಪಾತಿನ ಉಂಡೆ ಕಟ್ಟಿ ನೀವು ಅದನ್ನ ಲಟ್ಟಿಸ್ತೀರಲ್ಲ, ಅಲ್ಲಿ ತನಕ ಅದು ಫಿಸಿಕಲ್ ಚೇಂಜ್ ಏನಕ್ಕಂದ್ರೆ ಲಟ್ಸಿರೋ ಚಪಾತಿಯಿಂದ ಮತ್ತೆ ಉಂಡೆ ಕಟ್ಟಬಹುದು, ರೈಟ್? ಬಟ್ ಒನ್ಸ್ ಇಟ್ ಈಸ್ ಬೇಕ್ಡ್ over tawa, then it becomes chemical change. Okay, so next image, here there is a growth of plant. Growth of plant is example for chemical change. Chemical change because once the plant is growing from the seeds, it gets a new life and it cannot be returned back to the seed. You can tell ma'am, ಮತ್ತೆ ಅದರಲ್ಲಿ ಹಣ್ಣು ಬಿಡುತ್ತೆ ಮತ್ತೆ ಬೀಜ ಆಗುತ್ತೆ. ಹೌದು, ಬೀಜ ಆಗುತ್ತೆ, ಆದ್ರೆ ಸೇಮ್ ಬೀಜನ ಇಲ್ಲ, ಇಟ್ಸ್ ಎ ಡಿಫರೆಂಟ್ ಸೀಡ್. So cooking of food is also chemical change. So like this, there are many changes that happening in our surrounding, which we can broadly group as physical and chemical change. So just you should keep in mind, chemical changes produce new substances and it's generally irreversible, whereas physical changes produce no new substance and it is reversible and there is change in physical properties. Moving ahead. So let's understand the difference between elements and compounds. In the nature, there are 118 elements discovered so far. 118 elements are discovered. Okay, among that, almost 92 are natural. The rest are considered as man-made. Okay, so these elements are different from compounds. How are they different? Elements cannot be broken down into simpler substances. Element means it will have only one type of atoms, only one type of atoms will be there in case of elements, whereas compounds will have two or more types of atoms, more types of atoms will be there in case of compounds. So example for elements, copper, iron, hydrogen. It cannot be further divided. Whereas compounds will have water, methane, sugar. Example, water, methane, sugar. In case of water, it will have H2O. I can separate hydrogen and oxygen. In case of methane, it will have CH4. I can separate carbon and hydrogen. In case of sugar, it will have C6, H12, O6. Okay, oxygen, hydrogen, and carbon will be there, which can be separated again. So these are the main difference between elements and compounds. But both elements and compounds are pure substances. Because though compounds is having two or more elements, they are always in fixed proportion. Moving ahead, last one, that is types of elements. Elements, I said 118 elements are there. Those elements are broadly grouped as metals, non-metals, and metalloids. Metals and non-metals we have already discussed in our 8th standard. So metals are those which are lustrous. Lustrous means they have shiny appearance. Shiny appearance idre it's lustrous. Non-lustrous, they are non-shiny. They do not have shiny appearance. Whereas metals are good conductor of heat and electricity, whereas in case of non-metals, they are poor conductor of heat and electricity because no free ions, no free electrons. Okay, sorry, sir. Yeah, no free electrons are available for conduction of current. And they are ductile. Ductile means we can make into wire. Okay, malleable means we can make into sheet. We can make the metals get converted into wire and sheet, whereas non-metals are non-ductile and non-malleable. Sonorous means they produce a ringing sound, as we have seen bells of temples, churches, or even schools, school bell, they produce ringing sound. Whereas non-metals are non-sonorous. And example for metal, Cu, copper, Fe, iron, Zn, zinc, Au, gold, Ag, silver. Non-metals, carbon, S, sulfur, O, oxygen, N, nitrogen, P, phosphorus. So metalloids are generally having intermediate properties of that of metals and non-metals. And the examples are B, boron, Si, silicon, Ge, germanium. Got it, children? So I'll move ahead to discuss the difference between compounds and mixtures. What are the difference between compounds and mixtures? Mixtures do not have fixed composition as compounds do. Here, elements or compounds just mix with each other. They just mix physically. They are physically combined. This you should remember. In mixture, they are physically combined. Physically combined. Whereas here, compounds, they react with each other and they chemically combine. Chemically combine in case of compounds. And in mixture, they'll have variable composition. As I said in the beginning of the chapter, 1 spoon of sugar with water is also a mixture. 10 spoon of sugar with water is also a mixture. Whereas in compounds, fixed composition will be there. And in case of mixture, it shows the properties of constituents. For example, sugar in water. Does taste of sugar is retained, right? Does it loses the taste of sugar? No. The sweetness is retained. Similarly, property of water, able to flow, fluidity, that's also retained, right? It can flow. So it shows the properties of the constituents. Whereas in case of compounds, it shows entirely different properties from that of constituents. For example, let us take carbon dioxide. It contains carbon, okay, and oxygen, right? Oxygen. Actually, oxygen is supporter of combustion. Supporter of combustion or burning. ಆದರೆ carbon dioxide is used for extinguishing fire. Extinguishing fire because it will put off the fire. So, oxygen is supporter of combustion that's never shown in carbon dioxide. It loses the property, original property is lost. And mixtures can be separated by physical methods. We have discussed 6 methods already. That is evaporation, centrifugation, separating funnel, and even distillation, chromatography, sublimation. These things we have discussed. So it can be separated by physical method, whereas compounds can be separated only by chemical methods. For example, from H2O, I want to separate water and oxygen. I should do electrolysis, which is passing current and it splits the water. Okay, splits the water into hydrogen and hydrogen and oxygen that involve chemical reaction. So in case of compounds, it can be separated only by chemical process or even electrochemical process. An example for mixture, salt and water, air is a mixture, soil is a mixture, sugar in water is a mixture. All these are mixtures. We have discussed lot many examples of mixtures in the previous videos. Then coming to the compounds example, water H2O, methane CH4, carbon dioxide CO2. Got it, children? So these are the difference between mixtures and compounds. So till now we have discussed a lot about is matter around us, pure, which is a quite lengthy chapter. Hope my videos are helpful to you to understand the chapter much better. And if you have liked my videos, please share with your friends and do subscribe my channel. Keep waiting for another chapter video that will be uploaded shortly. Thank you.